Looking at the mean value theorem for derivatives, this one states that if a function is continuous on the closed interval and differentiable, notice the requirements, differentiable on the open interval, then there is at least one x equals c on the interval a to b such that this is true. And so first thing I think is helpful is if you illustrate this on a graph, and notice this little sketch I have right here is continuous and differentiable from a to b. And if you look at this equation, this right side, f of b minus f of a over b minus a, you should recognize that as just your old-fashioned algebra 1 slope. So whatever the slope is from a to b. So if I draw a line from x equals a to x equals b, and I think about that slope, whatever that slope is, f prime of c must equal that. And f prime of c means the slope at a point. And so if I just copy that and drag that around, there is a point on this graph where the slope at that point, the value of the derivative, does equal the slope from point A to point B. And as a matter of fact, as I have drawn this graph, there are two such points. There's one right here as well. So you're guaranteed at least one, and there could be more than one point. And so I guess for this instance, we could say there's a C1 and a C2, where the slope of the tangent is the same as the slope of the secant that connects the endpoints. So a couple of more concrete examples from previous AP exams. This is a table of values that represents Ben riding a unicycle back and forth on a track. We have B of t, which represents Ben's position, and they do tell you that B is a twice differentiable function, and that is important. So we have a differentiable function, which means every theorem under the sun as it relates to AP calculus is fair game. And so B is the position measured in meters. And then we also have a row for the velocity measured in meters per second. And one of the questions on this free response was, on the interval 40 to 60, must there be a time when the velocity is equal to 2 meters per second? And because there is a row for velocity, my initial thought on this problem is to consider the intermediate value theorem. I have a row for velocity. If position is twice differentiable, then velocity must be continuous. And so what I would really love to see is for this, instead of being 2.5, I would really love for that to be 1.5. Because if velocity goes from 1.5 to 4.6, then it will absolutely cross 2 at some point on that journey. However, that was not 1.5, it was 2.5. So while the intermediate value theorem is worth thinking about, it very quickly fails, which means we now need to consider another approach to determine this. And what you have to remember is that Ben's velocity is the same as the derivative of Ben's position. So let's think of it, instead of a velocity question, let's think of it as the derivative of position. And any time you are asked to guarantee, or is there a time when the derivative equals something, I would start with the mean value theorem. And so if I'm going to try the mean value theorem, now I'm going to consider this information right here. And if you're going to use the mean value theorem to justify any kind of a statement on the free response portion, you must establish the requirements for the mean value theorem, which is that your function is continuous and differentiable. So I'm going to start by saying that B of t is continuous and differentiable, right? So there is my laying the groundwork for the mean value theorem. Then I'm going to say, therefore, the mean value theorem, and you don't have to state the name of the theorem, it just looks good. So the mean value theorem guarantees that b prime of t is equal to, and we're on the interval 40 to 60. So b prime of t would equal b of 60 minus b of 40 over 60 minus 40. And we're going to hope that we get 2, and in this case we will, because we have 49 minus 9 over 20, and that does clean up to 2. And that will be for some t. I completely misspelled sum. For some t on the interval 40 to 60. So there is a mean value theorem question from an old AP exam. Okay, so here's a multiple choice one. So we have a function, and they are giving you the first derivative. They are telling you that f of 1 and f of 5 have values of 7 and 11. And then they ask what value of x satisfies the conclusion of the mean value theorem on 1 to 5. Well, mean value theorem says that f prime must equal f of 5 minus f of 1 over 5 minus 1. And they gave you the values for f of 5 and f of 1. So that will be 11 minus 7, which is 4 over 4. And that is a nice clean 1. So we replace the f of 5 with 11. I meant to do that in green. 11, that's 4. And so now what we're going to do is we're going to set the derivative equal to 1. 2x squared minus 5 over x squared must equal 1. And we're going to solve that equation. Let's multiply by x squared, move that x squared over. X squared is 5, and we actually get a solution algebraically of x equals plus or minus the square root of 5. And I'm kind of disappointed that they don't have the negative square root of 5 on here. But the reason we disregard the negative is because we are on the interval 1 to 5. So make sure that if you do happen to get multiple solutions algebraically for the setup, that you only choose the answer that is on the interval specified. And there are a couple of mean value theorem questions.